Chapter 10, Waves and Sound. Section 10.1, Vibrations and Waves. So by now you have some concept of what it means to say something is vibrating. In your textbook, a vibration is defined as a wiggle in time. But when something vibrates, just wiggling, shaking back and forth. A wave is just that vibration in time that then travels through space. It is basically a vibration in space and time. For example, if you have a bob moving back and forth, vibrating up and down, think of a mass or something attached to a spring. Put a pen or a pencil on the mass that's oscillating back and forth. It's going to trace out a sine curve. It's going to look something like this, where you have a wave that forms in this general way. As this thing moves up and down, the pencil is going to sketch out this sine curve. And so when we talk about waves, we first have to ascribe some characteristics to them. What we call the crests of a wave are the high points of a wave. The troughs of a wave are the low points of the wave. The amplitude of the wave is the distance from the midpoint of the wave to a crest or trough. And then the wavelength is the distance between two successive identical parts of the wave. So for example, the top parts of the waves are crests. The bottom parts of the waves are troughs. The amplitude is the distance from this midpoint line to the crest. It would also be the distance from the midpoint line to the trough. These two amplitudes would be equal. And then the wavelength is just the length from each successive point in the wave. So the length until the wave starts back over. So you can measure it from crest to crest, you can measure it from trough to trough, or you can just measure it from two identical points in the wave. In addition to amplitude and wavelength, the last thing we need to know about a wave is how quickly it vibrates or oscillates. The word oscillates just means moves back and forth. You will hear me use that word with vibration throughout the chapter. In terms of how the wave vibrates, we can measure the number of vibrations in a given amount of time, or more particularly, the number of vibrations per second. And we call that the frequency. The frequency is measured in vibrations per second or oscillations per second. And we give those units the measurement of hertz. So a frequency of 60 hertz would mean that it oscillates back and forth 60 times every second. Frequency of 120 hertz would mean it oscillates back and forth 120 times every second. Conversely, the period is the time it takes for it to complete one oscillation or one vibration. And so the period and the frequency are inherently linked. The frequency is the number of vibrations you can get every second, and the period is the time in seconds of one single vibration. So the frequency and the period are inverses of each other. The frequency is just 1 over the period, and the units measured are hertz. The period is just 1 over the frequency, and the units measured are seconds. If we know one, we know the other one. And as we'll see, the source of all waves is something vibrating back and forth, something oscillating. Vibrating in space, vibrating in the air, vibrating in the water. The higher frequency, or the faster something vibrates, higher frequency waves imply an increased rate of energy transfer. So what that means is that higher frequencies can transmit energy easier and more quickly than lower frequencies. And we'll see more of this as we go through this chapter and the next chapter.